I'm Effie Parks. Welcome to Once Upon a Gene, the podcast. This is a place I created for us to connect and share the stories of our not-so-typical lives. Raising kids who are born with rare genetic syndromes and other types of disabilities can feel pretty isolating. What I know for sure is that when we can hear the triumphs and challenges from others who get it, we can find a lot more laughter, a lot more hope, and feel a lot less alone. I believe there are some magical healing powers that can happen for all of us through sharing our stories, and I'll take all the help I can get.
Once Upon a Gene is proud to be part of Bloodstream Media. Living in a family affected by rare and chronic illness can be isolating, and sometimes the best medicine is connecting to the voices of people who share your experience. This is why Bloodstream Media produces podcasts, blogs, and other forms of content for patients, families, and clinicians impacted by rare and chronic diseases. Visit bloodstreammedia.com to learn more.
Hello, and welcome to the show. This is Once Upon a Gene, and I'm your host, Effie Parks. And before we dive in, I want to take a moment to recognize that this episode is coming out just before Rare Disease Day, a day that shines a light on the incredible strength, resilience, and advocacy of our rare disease community. To every family searching for answers, every researcher working toward breakthroughs, and every advocate fighting for better care, this day is for you. You are seen, you are heard, and your efforts matter. No matter where you are on your journey, know that you are not alone. There are so many activities and webinars and in-person events that you can join this Rare Disease Day. So I encourage you to go find something or simply just watch online from social media. And I hope that it invigorates you. I hope that it connects you. This is a day to be with your people in person or in spirit. So happy Rare Disease Day. I will see you at the Brigantine in San Diego on Rare Disease Day, Friday, February 28th at 4 o'clock. There may still be tickets available. I doubt it, but you should check. Follow me on social media and learn about the rare disease event that we're hosting in San Diego. Speaking of that event, I'm speaking to the CEO of PacBio today, and they were one of the generous sponsors for our event, and I'm so grateful for them. So thank you so much. So we're talking about PacBio. It's a company that's at the forefront of long-read genomic sequencing. If that sounds technical, don't worry. He's breaking it down in a way that makes sense. He's going to explain how some genetic tests miss critical information, how PacBio's technology is helping to solve rare disease mysteries, and why families who've already had whole genome sequencing might want to go take another look. We're also going to talk about the future of genetic testing, what's next, and how this could become a routine part of medical care, and what it means for rare disease research. It's an exciting and hopeful conversation about the power of science, technology, and persistence, and PacBio is leading that charge with genetic testing and their technology. So I hope you enjoy my conversation with Christian Henry. Hi, Christian. Welcome to the podcast.
Hi. It's good to see you. Thanks.
Yeah, I'm looking forward to having a chat about genetic testing. It is one of my love languages in rare disease. But before we get into all those details, can you please introduce yourself and tell us a little bit about your role at PacBio?
Yes. So my name's Christian Henry, and I'm the President and Chief Executive Officer of PacBio. I've been the CEO of PacBio since September of 2020. And for those of you that don't know much about PacBio is a sequencing company. And our specialty is looking at long fragments of DNA, so long-read sequencing. And we have a whole portfolio of products that serve several different communities, from basic research to clinical testing. Our products have been used in rare disease research, oncology, and even plants and animals and infectious disease. And we're a global company, so we have operations all around the world, and we have customers that are using the technology every day to advance our understanding of the genome.
I was going through your website earlier this week, and the amount of products on your website were super fascinating to me. And you're definitely leading in this industry at this point. And for those who don't necessarily totally understand what long read sequencing means. Can you explain it to us in simple terms and how it's different from the traditional genetic tests families might know about?
Yeah, I absolutely can. So, over the last 30 or 40 years, we've made incredible advancements as a community in improving our ability to understand the genome and its relationship to disease or characteristics. And there's been a number of different technologies over the years that have helped. What we do with long read sequencing is that we are able to isolate very long single molecule fragments of DNA and sequence those. And so what sequencing is, in simple terms, is each of us has four letters, four bases, A, C, G, and T, and they're strung together to form our DNA. Unraveling that string is what our technology does, along with others. We do it a little bit differently in that we are able to look at longer pieces of that string. And by being able to look at longer pieces, we can see parts of the genome that other technologies can't see. And that gives us an advantage because we're able to uncover some of the characteristics or mysteries of the genome and some of the other aspects of the genome that other technologies may not be able to uncover. And so our technology is, we've had the company for about 20 years, give or take, a little bit more than 20 years at this point. And we've launched several new generations of product. And the latest generation is highly, highly accurate, brings the cost of looking at one whole genome down to $500 a genome for any customer actually that decides to use our technology in their analysis. So hopefully that gives you a little sense of we're deconstructing the string of DNA one base at a time and connecting that to diseases or other characteristics that someone may have.
It's so amazing as a parent whose child had whole exome sequencing a little under 7 years ago was at $30,000.
Yes, it is. It's mind-blowing. And I've been in this industry a long time and in the sequencing market, almost 20 years at this point, actually more than 20 years. And the costs have come down from millions of dollars to just, $500 or less. And the quality of what you can see now is just revolutionary. In fact, not only can we understand the string itself, but we can understand little molecular molecules that impact that string of DNA and regulate the way that functions. And the combination of understanding the letters plus the regulation dramatically improves our ability relative to an exome to see the whole picture. And particularly in rare disease, where by its very definition, the diseases are rare, it gives clinicians and researchers the ability to, uncover the mystery, which is so gratifying for me. It's actually why I do this, because I think there's so many people that could be helped with this technology.
Of course. And some families have already had whole genome sequencing and they still don't have an answer. Should those families consider going back and having their data reanalyzed using PacBio's technology, or what makes this different from what they've already done?
Well, the first thing I would say is that the technology and our understanding of the genome is advancing every year. And so, staying connected with your physician or your researcher or whoever you're working with to understand what are the latest advances in the field and could that maybe help. And, long read sequencing, which is what we do, has only recently really become affordable over the last few years. And so you're seeing many, many more patients using long read sequencing in their analysis. And I think that's creating an explosion of understanding. And so, for the families that are still struggling, there is hope. I think that's one message that's so important, is that we are just at the beginning of understanding the nature of the biology, and tools like what we provide at PacBio are giving, families new hope. So I do think that, continually working with your physician, working with researchers, can help you evaluate whether you should go get sequenced again.
So let's talk about that affordability and accessibility, because I know families are still being denied a lot of the time and given that sort of spiel about how it's unaffordable still and to wait and to maybe do panels instead. So is PacBio doing anything in particular to bring down these costs that make the long read sequencing more available to families like that, families who are speaking to their clinicians and maybe not getting the correct information? Like, are you helping to bridge that gap with families is my question, I guess.
Yeah, so we are a technology creator and a technology provider. So we provide the technology, the tools, the software, the analytical abilities. It is an entire ecosystem. So we're just part of the ecosystem, and so what we do is we work with researchers and clinicians to give them access to this technology so that they can do the studies to demonstrate the value. And what we're trying to do, the way we contribute specifically is that, we give very low cost sequencing in certain research studies to enable that research to get done, which continues to prove why using long read sequencing is so important. And by doing that, it gives the clinicians and ultimately the payers and providers more reason to pay for this, which I think ultimately gives more access. But it is certainly a long and frustrating road because we have dramatically taken the cost of the technology down. But, the whole problem is much bigger than even just us. So we're contributing, we're doing our part, so to speak, and doing everything we can. But there's a lot more to the story.
Yeah. Could you maybe list me two of the pain points right now, maybe the biggest challenges in making this sort of long read sequencing more accessible?
First pain point is really all about making sure that the world understands that this whole genome sequencing using long read technology, especially PacBio, is completely accessible now, where just a couple of years ago, it was completely out of reach. And so what we've done is we've partnered with groups like Children's Mercy Hospital in Kansas City, and they've been really advancing the state of the art of interpreting rare disease genomes and leveraging our technology, so much so that they're using our technology now as the first line of defense. In other words, the first line test. They're trying to move from panels and exomes straight to genomes because in the long run, running the genome first is actually less expensive, and it's being demonstrated time and time again that you're getting more answers and you're getting more, your families are coming away with a greater understanding of their situation, which I think is so critical. So that's, the first thing is generating the awareness now that the technology is out there, and partnering with groups like Children's Mercy Kansas City. Another group that we're partnered deeply with is Radboud Medical Center in the Netherlands, where they're using our technology in rare disease as well. And they've recently committed to doing 5,000 rare disease patients using our technology. And so you're really starting to see a watershed moment. The second pain point that we're working to manage is helping clinicians and researchers understand the data better. And so developing new bioinformatic tools, new software that allows the clinician to more easily link genotype or the genetics with the phenotype or the symptoms that a patient may have. And so we're investing a lot of our time and money and effort into building better tools that make it easier and faster for a doctor, to make a decision. We're also partnering with other groups to help link different rare disease groups together so that when they see something rare, they can share it with their colleagues, whether it's down the street or around the world, in a seamless sort of way so that the entire community can get better answers. And so those are probably the two pain points that we're laser focused on.
Very cool to know about the Mercy Hospital. I see them in the news all the time doing such amazing stuff for rare disease, and also great about the Norwegian point too, because I want to share that with my families over there. The second part that you mentioned, I'd love you to maybe dig into that a little more on how you are collaborating with those groups to sort of give that information to connect these diseases together. Or can you speak on that?
Well, yeah, so we partnered with a group called DNA Stack, and what we've done is developed a way in which If you are a researcher at Children's Mercy, perhaps, and a researcher maybe in Tokyo, we'll just use that as an example, you have a database that you've built up on looking at patients in rare diseases. And through this partnership, we're developing tools that allow the data to be what we call federated. So even though the data isn't actually moving across borders or moving between institutions, you can see into the data and understand, hey, this clinician over, maybe I'll use a more of a US example. This clinician at Children's Hospital in Philadelphia perhaps saw this one case with this one and uncovered a genetic issue associated with a particular set of symptoms. I'm at Children's Mercy now, and I have a similar set of symptoms, and I can actually query the databases much more easily. And that helps me get to a decision, a clinical place to go and look much, much faster. And so by federating that data, we can facilitate faster answers. And also, one thing I think is really important is that industry has to help advocate and create community, just like all of the community advocacy groups are doing already for their specific diseases. We're trying to do it a little bit more on a global basis because we know rare disease is actually quite common. It's a misnomer because there's so many different types of diseases that are genetically based, and we're in a great position to see all of that. And if we can create community, I think that really helps push the whole field forward. So that's how we're looking at it.
Amen. And I think even just as a parent listening to that, I think, oh, music to my ears, first of all, if that communication can be passed through. But then also it could be relayed to the families that are already diagnosed and pass them on to a family in their local area to have that connection just immediately, right? And just connect all those dots right away. So even if a family does have a diagnosis, they're still not completely lost and alone and isolated right from the beginning.
Yeah, and I think that's so important. As this field's evolved over the last 10 or 15 years, I think there's a huge recognition that not every rare disease can necessarily be treated, but getting to diagnosis and drawing a conclusion of what's really happening is profoundly important to parents and profoundly important to society so that we really know how to manage these diseases better, so that we can give families peace of mind as they think about potentially expanding their families. And I think that that's pretty gratifying to see that happening. And we are a company and we are really the technology provider. But to the extent, our mission is really to enable the promise of genomics to better human health. To the extent we can help groups like Children's Mercy advance the state of the art, that's really moving us towards our mission, and it's what really keeps us going to keep creating amazing technology.
I can tell that it isn't just a product and that you've definitely done your homework. You've been highly engaged in one way or another with these patients and these advocates. So thank you for that. I can tell that you speak a lot of our language just as families and sort of understand the urgency there for us. I don't know if you know, but I live in Seattle, Washington, and I know you had a collaboration with my friends over at GeneDx and then our university and our children's hospital, and I wondered if you could maybe give us an update on that because I know it's been going on for a while. I'm not sure if it's over and what happened with the sequencing there.
Well, we continue to collaborate with GeneDx. They already are a customer of us, and they're doing amazing work. I'm good friends with Catherine Stuhlin, the CEO over there, and she's on a mission to help families with rare disease and with genetic testing and really bringing it to the masses. And we're standing behind them 100%. And one of the things we did last year together is we analyzed a large cohort of samples together and found dozens of different genetic traits that could be implicated in the disease. And as I'm sure many of your families that are listening know, it is looking for a needle in a haystack sometimes. And so, bringing the latest tools to bear, bringing more samples, collaborating with groups like GeneDx, that really helps us move forward. And we actually have great relationships with the children's hospitals, and University of Washington has been huge advocates of our technology. And so we have really deep relationships there too with a lot of our technology. In fact, one of our scientific advisory board members, Jay Shinduri, is actually at University of Washington as a very prominent researcher there. So lots of deep ties.
That's really exciting. So how can this type of sequencing help move that needle toward developing treatments for rare diseases?
There's a couple of aspects. The first thing is that we have to continue to make long-read sequencing more ubiquitous because it is the most comprehensive way that we've discovered to understand the genome. As I talked about before, not only do we understand the letters of the genome, but we understand the regulatory elements of the genome. We also understand, other sequencing technologies have a hard time figuring out when there's big structural changes to the chromosomes, and those structural changes can often be implicated in rare disease. And so the first thing we have to do is keep advancing the state of the art of technology. The next thing we have to do is, as we identify those markers, perhaps there's druggable targets against those genetic anomalies, whether it's potentially the world of RNA editing is becoming a really important set of technologies, or different kinds of gene therapy, perhaps cell therapy even. So there's a whole host of different therapeutic areas that will leverage the discoveries that are made through the comprehensive understanding of the genome. And I'm sure for any parent that's listening, they can't come fast enough, but you can be assured that, companies like PacBio, we're investing hundreds of millions of dollars into advancing the state of the art so we can improve not only our understanding or the diagnosis, but also contribute to the potential therapies as they advance forward.
So how can families collaborate with PacBio to help accelerate these discoveries?
Well, I think the first thing is really working with your clinician and looking to the extent you have the ability or access, certainly participating in the advocacy groups, volunteering to participate in the research, to the extent that that's feasible. Those are certainly the areas straight out of the gate that really come to mind. For PacBio specifically, we are, as I said, we're kind of behind the scenes, right? We are providing the tools for the people on the front line. But by advocating for long-read sequencing, I want the most comprehensive view of the genome. That really helps us because that helps push our technology forward, allows us to drive deeper into the market. And because our technology is the most comprehensive and is now very, very cost effective, it just makes sense. And that's why you see groups like Children's Mercy moving into a frontline diagnostic test, because in essence, what they're really doing is replacing all kinds of legacy tests, from single gene panels and what are called PCR-driven tests to the exome to short read whole genome sequencing. People probably have heard that term in the past. To now, I can, in one test, at one time, I can get a comprehensive view of the genome, and I can get a comprehensive view which gives the clinician the best chance of unraveling the mystery of that particular disease. That's probably the best way to advocate for us.
Well, technology is moving so fast, and I know that bureaucracy and regulations could move at a glacial pace at best. Are there any things that you at PacBio are hoping or working toward to change to help this more widely integrated into Medicare and just things move faster in general?
And this is a crazy time we live in right now with, a lot of uncertainty around government funding and the National Institute of Health funding. The research that's going on through the National Institute of Health that's funded into universities and into other groups around the world really is profoundly important to advancing the state of the art of genetics and our understanding of rare disease in particular. And I think that when families think about how to advocate locally for funding, is really thinking about, electing officials that really understand how important scientific research is. And everyone has different politics, so I'm not really going there, but I really believe that, the United States has led the world in genetics and genomics. The leading sequencing companies in the world are all coming from the United States. There's no coincidence there. We've historically had the best funding environment for research, the best funding environment for advancing the state of the art, which ultimately helps patients. And we, as a country, I believe it's important that we continue that track record because we still know so little about the genome. We know so little about how the genome impacts rare disease, but then also the relationship between the environment and the genome. And so when families are thinking about how do I really make a difference, it really is thinking about who are the elected leaders we're working with to make sure that they're advocating, for the research, they're advocating for equality of coverage. It is so important. And one of the things that we are doing at PacBio, and I think the entire sequencing community is doing, is we're trying to expand the amount of sequencing done across the different populations of humans. Because in reality, most of the research has been done on European ancestry. And only over the last 6, 8, 10 years have we been trying to emphasize more and more looking holistically at Asian populations, at African populations, because there is genetic differences that are implicated in disease. And so when families are looking at how to advocate, it's also advocating for the diversity of sequencing, because this is one area. By understanding the genome for all the different ethnicities and ancestries, that really helps the total research, and it'll help all of us.
Yes, that makes me think of one of my favorite researchers, Claudia Gonzaga, who has her program in Mexico and Latin America to get all those genomes in.
Yeah, in fact, right now we just started a collaboration with a group in the UK on looking at RNA sequencing. So the translation from DNA to RNA using our long read capabilities for populations in South America. Throwing that out there.
Very cool.
Lots of fun.
Yes, I can tell it's very exciting for you too. That's great.
Yeah.
Looking ahead, what do you think the next 5 years are going to look like for genomic sequencing? And what are maybe your like big, hopeful money shot goals?
Yeah, I think if you look out over the next 5 years, right now we're in this incredibly fruitful period of expanding the technology to understand the relationship between the letters of DNA, and the regulatory aspects. And you're looking at, and that's going to have massive implications in oncology, in rare disease, in cardiovascular disease. And so really uncovering not just the genes themselves, but how the regulatory elements impact disease. I think the next 5 years, you're going to see amazing progress in that area. I also think over the next 5 years, long-read sequencing will continue to explode. In fact, long-read sequencing is, over the last 5 years, long-read sequencing has grown dramatically faster than short-read sequencing because there's just so much more information to be gathered. I think that trend will continue, which will enable us to have deeper databases that get to answers faster than ever before. And I think over the next 5 years, one of the things I'm really excited about is the ability to integrate not just the DNA, but the RNA, and then perhaps even proteins, and then using AI-driven informatics to start to make sense of all the molecules that are interacting with each other at any particular state. And I mean, that might take longer than 5 years to really get that, but that's really the ultimate end game, is to try to understand all of the different biological molecules that we're interacting with, whether it's a protein or a RNA molecule or a DNA molecule, or maybe even perhaps the sugar molecules that are floating around in your blood. Thinking about all of that together, looking at it as an integrated system. And that systems approach is really how I think in the long run we'll be able to make really amazing decisions. And we're going to need a lot of AI to really help us with that. That's for sure.
Good thing that's up and coming too. And just, at the base level, I imagine that day when a family doesn't have to wait in complete agony for months and years for that answer. So
one of the things that our technology is doing, even right now, it's dramatically accelerating the odyssey. People are starting to see that they can go straight to a long read whole genome and skip all those steps in the middle. Someone recently showed me a presentation where they looked at the diagnostic odyssey like the game Chutes and Ladders, if you know that game, where you climb up a ladder and make an advance, and then you move a few steps forward, and then you slide down a slide, moving backwards because of this odyssey that you're on as a family. And I can only empathize with the families that are going through that every single day. But as you move to long read technology, the ladders tend to be a lot longer and there's fewer slides, to put that analogy to use. That day is here now. It's advancing. It's going to continue to improve every single year. And so there's a lot of hope for those families.
Yeah, thank you. I was actually going to ask you to basically give me some piece of wisdom for the families. And I think that's a perfect way to say it. I love the chutes and ladders visual.
Yeah.
It makes a lot of sense. Well, Christian, is there anything that I haven't asked you that you want to leave with any of our listeners?
Well, I think the first thing is that we at PacBio are, first of all, we're grateful for this opportunity to sponsor this and be part of this journey. I also think it's great that we're recognizing rare disease around the world, and groups are doing something about this. And, it inspires me and motivates me every day to, come and create this technology and promote it to the world so that we can, help people's lives. And our goal as a company is to help people with hope and with opportunity. And I think as we continue to grow and spread the technology, I think there's going to be more cases solved every single week. They're going to get faster. And if you look out over the next, every year we're going to advance, and it's advancing at a pace that's probably much faster than people could have ever imagined, but it's still not fast enough. And we're fully committed to going as fast as we can to help as many people as we can.
Thank you so much, Christian, for this conversation. And really thank you so much for breaking it down. It's such a complex topic, and you've explained it in a way that I know families can truly understand. And it's really incredible to hear how PacBio's pushing these boundaries of what's possible and what's next for rare disease. And I can hear your passion. It's clear. And I know so many families are going to appreciate all the progress that you're contributing to. So thank you so much. The future is bright. And yes, thank you so much for being one of our sponsors for our fabulous Rare Disease Day event that we're having in San Diego. I hope to see you or some of your team there. It really means a lot to us that you're supporting the troops on the ground for Rare Disease Day and the families that get to show up and be together. So I'm very grateful to you and to your team. And thank you so much for explaining this to our audience today.
Well, it was my pleasure, and I look forward to chatting with you again at some point.
I hope you've been enjoying this podcast. If you like what you hear, please share this show with your people, and please make sure to rate and review it on iTunes or wherever you get your podcasts. You can also head over to Instagram, Facebook, and Twitter to connect with me and stay updated on the show. If you're interested in sharing your story, or if you have anything you would like to contribute, please submit it to my website at effieparks.com. Thank you so much for listening to the show and for supporting me along the way. I appreciate y'all so much. I don't know what kind of day you're having, but if you need a little pick-me-up, Ford's got you.